Yeah, hi. So we'll be doing today this question, which is paper 1, section B, question 5. Okay. So it is paper 1, section B, and question number is 5. The question reads out like this. The question is for hydrogen and lithium. Okay, atoms given. Okay, na? So for hydrogen and hydrogen atom, and for lithium atom. Okay, so for hydrogen atom and lithium atom, orbitals energies were mentioned. Orbital energies are given is for hydrogen, energy of 2s is represented as E2s and energy of 2p is represented as E2p. Okay, similarly for lithium atom, okay, not lithium ion. Lithium atom means it is multi-electron atom. Okay, so as mentioned, energy of again 2s is E2s and energy of 2p is E2p, like that is given. Okay, so after that he is asking is which options is or are correct, which is multi-correct one. Okay, so as we know that for one electron atom, that is hydrogen atom, always all the subcells belonging to a particular orbit are equal energy. Okay, all subcells belonging to particular orbit means what? E2s will be is equal to E2p. Okay, this is for hydrogen. Okay, na? So this is only given as first option. Na? So first option is given as energy of 2s and 2p. If both are belong to second orbit, you can see 2s and 2p both belong to same orbit. So both will be same energy only. Okay, so this A option is correct then. Okay, then second option. Second option is can you show the question? Yeah, second option is telling that first option, this is second option. Okay, so this is B option, which is hydrogen and like hydrogen 2s and 2p is correct. Okay, now first option. So first option, if I write first option is given as energy of 2s of lithium is less than energy of 2p of lithium. This is first option given. So it's given as for lithium, that is for 3 electron atom. Okay, lithium atom is telling that energy of 2s is less than energy of 2p. So this is also correct only. Okay, why this is correct? Because always for multi-electron atom, the energy is like this. 1s is less than 2s, is less than 2p, is less than 3s, is less than 3p, and so on, right? So this is for multi-electron atom. So as for multi-electron atom, 1s is less than 2s, is less than 2p is less than, like that it continue. That's why energy of 2s is less than 2p. That is first option, which is also correct. Okay, now we'll go to third option. Okay, third option is energy of 2p of hydrogen is less than energy of 2s of lithium. Okay, he's telling that energy of 2p of hydrogen is less than energy of 2s of lithium. So we can't compare like that. Okay, it is not that easy to compare for two different atoms, that two different orbitals if given. We can't compare. So this is not the right answer here. Now if you go to option D tells that energy of 2s of hydrogen, is greater than energy of 2s of lithium. Now you can do comparison because both are 2s and 2s given. Now you can do comparison. See, lithium is having 3 protons. Lithium is having 3 positive charges and the electron is present in 2s. And for hydrogen also, there is only 1 positive charge present for hydrogen and the electron is present in 2s. So obviously, which electron will be attracted strongly by the nucleus? Lithium's electron will be attracted much strongly compared to the hydrogen. Right? So if this electron is attracted very strongly, then this will have more negative energy, and this will have less negative energy. Is that clear? So negative sign has mathematical significance. So hydrogen has less negative, meaning is overall hydrogen has more energy than lithium. Okay, due to negative sign means it is like if imagine ki this is -5, this is -3, then which is greater? -3 is greater than -5. So that is why hydrogen is greater than lithium. Okay, so this option is also correct. Okay, na? So answer will be A, B and D overall. So answer is A, B and D. These three options are the correct ones. Fine.
Paper 1, question number 6. So this concept has, the question has both redox reaction as well as, it is mixed with chemical bonding. Okay, MnO2 reacts with concentrated HCl, which gives MnCl2. Green yellow gas means that will be Cl2 in presence of water. I will write complete reactions, then we will go with options. I'm solving now paper 1. Paper 1, section 2, question number 6. The question is given reaction MnO2 plus concentrated HCl gives MnCl2, and it is giving Cl2 with 2 moles of water. The color here is greenish yellow gas, Cl2. NH3, that Cl2 is reacted with NH3, which gives NCl3 plus 3 moles of HCl. 3 here, 4 here and 2 here. That Cl2, the same X, this is X, this is X, this is Y, this is X, reacts with 3 moles of F2, which is taken in excess, gives 2ClF3. Let us see options. This is Z. X is used for sterilizing drinking water. Yes, this is conceptual. Option A is correct. B is, Y is planar. Do we get planar structure if you see nitrogen valency, number of unpaired electrons, that is 2 we have, and it is pyramidal. So option B is not correct. Option C, Z. Where are we getting Z? Here. The last structure is used in enrichment of uranium-235. That is, application of this. So option C is correct. And Y, where do we have Y? Yes, this one is stronger Lewis acid than ammonia. Stronger Lewis acid than ammonia. NH3. Is it stronger Lewis acid than ammonia? No. So, here in question number 6, paper 1, section 2, A and C are correct.
Question number 7 from paper 1. A very simple question direct from NCERT. So the reaction between oxygen and PTF6 is given. So they have mentioned there are 2 compounds, that is O2 and PTF6. So O2 will combine with PTF6 forming O2 plus and PTF6 minus. This is the equation which prompted Bartlett to prepare the first noble gas compound. So very important, direct from NCERT, very simple question. Now they have asked, combine this one with chemical bonding. So O2 plus bond order is asked. So it has the configuration, it will have 15 electrons. The configuration is sigma 1s, sigma star 1s2, sigma 2s, sigma star 2s2, sigma 2pz2, pi 2px, 2 pi 2py2 and pi star 2px1. If you consider the outermost orbital, the bond order will be equal to 2, 4, 6, 6 minus 1 by 2, that is equal to 2.5. Therefore, the option A is actually correct answer, 2.5. Bond order is 2.5. Is 1.5, therefore this option is wrong. This option is wrong, bond order given is 1.5, it is actually 2.5. So the next one, PTF6 minus, what are the number of d electrons here? So The configuration of PT is xenon. It has D9 electrons and 6s1 and 4f14. So in this compound, the oxidation state of platinum is X is equal to +5. So it loses 5 electrons. So those 5 electrons from 1 from here and 4 from here. Therefore PT in the +5 oxidation state is D5. D5 system. As a result, the number of electrons present in the d orbital is 5 is absolutely right. Option B is correct. The option C says that PTF6 act as an oxidizing agent. So that is correct because it oxidizes oxygen molecule. So that is correct. C option is correct. Option D, PTF6 act as a fluorinating agent. In this particular reaction, it is not donating any fluoride ion. It is not a fluorinating agent. Therefore, the correct answer for this question is B and C.
Question number 8 of paper 1. Now, this is a question based on combination of hydrocarbons, Friedel-Crafts alkylation, and then you have aldehydes and ketones involved in it. So it is a beautiful question. Let's try to solve it. But to begin with, you have a carboxylate. So 1, 2, 3, 4. So you have sodium butanoate. When sodium butanoate is subjected to Kolbe's electrolysis, there is going to be a decarboxylation, there's going to be loss of carbon dioxide and the reaction is going to proceed via formation of free radical. So you will end up in getting a propyl free radical. And two propyl free radicals are going to combine with each other to form N-hexane. And then subsequently in the next step, you are reacting it with vanadium pentoxide at a temperature of 500 degrees Celsius, 10 to 20 atmosphere. So in these conditions, there is going to be cyclization and subsequently aromatic compound is formed due to dehydrogenation. So you get benzene. So this is Q. And then in the next step, you have phthalic anhydride that is going to be reacted with anhydrous AlCl3. And during this reaction, there is going to be Friedel-Crafts acylation. This is a Friedel-Crafts acylation wherein the AlCl3 is going to form a coordinate bond with oxygen, and then in turn, the bond between carbonyl carbon and the oxygen is going to break, leading to formation of an acyl carbocation, and in turn, there is going to be acylation taking place. And subsequently, there is deprotonation, and as a result, you end up in having a carboxylic acid being formed as well. So let me draw the structure of that compound. Okay, so this is what we get, and that is compound R. And this R is going to be reacted with PCl5. So PCl5 is going to react with carboxylic acid to give us acyl halides. And then in the next step, you are going to react it with hydrogen, acyl halide, and then you are going to react it with hydrogen in presence of palladium sulfate. Where this gets reduced, acyl halides will get reduced to form aldehydes. Okay, so now I have got two carbonyl carbons at the end of this reaction, which is S. Now we are going to react it with hydrazine. And as you know that hydrazine is going to undergo nucleophilic addition elimination reaction as you are also providing heat. But also one thing has to be noted that in the first step your aldehyde is going to react with the hydrazine to undergo a nucleophilic addition elimination reaction, and then subsequently there's going to be an intramolecular nucleophilic attack, and then the elimination takes place. So this is what we end up in getting. So you have this nitrogen, which is in turn going to be bonded to another nitrogen. So this is the compound we get. Now there are certain options that corresponds to this. So let me read it out. And before that, this is T. Okay, now let's have a look at the first one. It says S upon reacting with ammoniacal silver nitrate solution, that results in formation of silver mirror. Yes, because we have an aldehyde, which is going to give us a positive result towards Tollens reagent. So A is right. And then B, option B states Q on treatment with excess of chlorine gives gemaxane. Yes, that is true, because whenever you are reacting benzene with excess of chlorine, you get BHC. So therefore B is also right. And then they have said T is a heterocyclic compound. Yes, it is a heterocyclic compound because I've got two nitrogens involved in this compound. Then next, they have also gone on saying that R upon reaction with R on acid catalyzed intramolecular cyclization and then followed by zinc amalgam. So which means, so when you are going to subject this to reaction with H plus, you will have formation of an acyl carbocation, and then subsequently there's going to be an intramolecular electrophilic attack leading to formation of a cyclic compound. So this is 1, 2, 3, 4, 5 and 6. So you will have a bond being formed between these two sites. So this is carbon 2. I'll start from here. This is carbon 1, 2, 3, 4, 5, okay, so this is 5 and this is 6. I hope the numbers are visible. Okay, and then subsequently you're going to react it with zinc amalgam and HCl. When you react it with zinc amalgam and HCl, it will undergo Clemmensen reduction. And in Clemmensen reduction, ketones are going to be reduced to respective hydrocarbons, and this is the compound we have got. But then the option says 9,10 dihydroxy anthracene, which is not correct. So therefore, the correct answers are A, B, and C.